Ornithology came to me as early as I was an undergrad. I was doing fieldwork in different places, and I just realized that birds share the same communication channels that we use. They use colors, they use sound in more or less similar frequencies and wavelengths that we use. What seems beautiful or sounds beautiful to them is what we can share as beautiful and as colorful. That makes them great ambassadors for the connection between nature and the human world. That intimate connection drew me to birds. Joining the Burke was really a huge game changer for me. Growing up scientifically around museums. During my undergrad, my mentor was the curator of ornithology at the Museo de Ciencias Naturales, which is in Bogota, Colombia. When I moved to the US to do my PhD, my mentor was the curator of birds at the University of Connecticut. I've always dreamed with being a curator and having this chance of realizing this dream in a place as wonderful as the Burke Museum. It's been amazing. I work with aerodynamics, I work with communication signals. The Burke has the largest spread wing collection in the world, and there is so many questions that we are interested in solving there. And now we are developing the tools to take advantage of those huge collections. After those golden days of being in this brand new museum and with these, wonderful people, and then, having to stop suddenly and go virtual was shocking. So we decided to reinvent how we approach the questions. Now that we have access back to the museum, we have designed our setups, our working and research setups to be social distant. We are interested in approaching this different way that some birds may have to communicate, which is using the UV channel.
Humans see light with 3 wavelengths, essentially 3 different types of cones. But birds have a 4th type, so they can actually see light in the UV range. And so what we want to know is, we know how birds look when they're behaving in certain ways or flying in certain ways, but we want to know how they actually look to another bird. So we're doing that with a lot of specimens from the museum, and we're actually looking to see how this light looks different when we have a special camera that can show just visible light versus light that's on other ends of the spectrum.
So here we're working on setting up this spectrometer for Alejo's research to look at quantifying color as it's reflected off of the birds. We might think the color's bland looking or something, but in UV it might look way different to a bird and be part of their signaling process.
What we want to also do is be able to capture how that angle differs and how the light reflects differently depending on the angle. My PI Alejo has been noticing that some birds actually, when they're flapping, they take a little pause. And it's not with every species, but it's with some species. And it's with species that we think might have something special about the coloration in their underwing, which then is sending a signal to another bird. It's just kind of like one more puzzle piece that gives us a bigger picture of what these birds are doing and how they're interacting with their environment. By working with hummingbirds, we start to really get into this conservation interest too, because people want to see a bird that's beautiful and doing something really interesting, and they want to know more about it.
Doing this work is being very challenging under the current circumstances, but we are very proud to have a team that is able to make this work, and we are actually now getting our first data from this setup. In order to accomplish this work and to work with these wonderful people, we truly appreciate your support to make these dreams possible. With your help, we are able to move forward at a faster pace, even during this challenging pandemic. And we are very grateful for that. Thank you.